In this video, we are going to change the way you think about angles. You learned about angles as the intersection of two rays. And you learned that there are a few different types of angles, like an acute angle, which is the one that we have on top here. Or an obtuse angle, which is the one we have down here. The thing about defining angles as the intersection of two rays is that even if this angle were upside down, it would still be an acute angle. And even if this angle was completely on its side, it would still be an obtuse angle. But what we're going to talk about allows us to think of angles in a different way. The first step is to talk about something called standard position. It's a really simple idea. Nothing that we're doing today is very tricky, it's just different. The idea of an angle in standard position is we're not going to think about angles as the intersection of two rays. What we're going to think about is that an angle is a direction, really a direction that is being pointed at. So when you have an angle in standard position, you really do have two rays. The first one is what's called the initial side. That's over here. It is always in that same spot. It is always the positive x-axis, and because it's always in the same spot, we don't even bother drawing it. We just leave it alone. That's where the initial side is. The other part of the angle, you can think of it as the other ray, is the ray that can point in any other direction, and we call that one the terminal side. That's that part right there, is the terminal side. When we measure the size of an angle, what we're going to really be thinking about is what direction is that terminal side pointing in. And the first thing that thinking about it that way does for us is it allows us to talk about angles that are bigger than 180 degrees. When we thought of angles as just two rays intersection, even if we flipped it upside down, an obtuse angle was still an obtuse angle, so it was still somewhere between 90 and 180 degrees. But if we think about angles in standard position as directions instead of just two rays, we can talk about angles that are bigger than 180 degrees. One important point is that the direction we're pointing in is always rotating around counterclockwise from the initial side. So always following in this direction like that. So a couple of quick examples of angles of different measures pointing in different directions. You could have a 30-degree angle that's pointing in this direction. You can have a 100-degree angle that's just a little bit past 90 degrees pointing in that direction. Those are a couple of examples. But because we are now going around in a circle and talking about the direction that an angle is pointing in, we can go past 180 degrees. And so if you go to 225 degrees, you're simply starting yourself on the initial side and rotating around past 180 degrees. And then another 45 degrees after that puts us exactly there. And so changing the way we think about angles allows us to talk about a different kind of angles. We can now go past 180 degrees, but we can do more. We can even go past 360 degrees. We know that it's all the way around a circle is 360 degrees, but we can go past that. The example that you see drawn here is 495 degrees. What that means is starting from the initial side, you rotate around. A full circle is 360 degrees, and just keep going. If you just keep going around, you can pass 360 degrees. Now, you might be pointing out, which totally makes sense, isn't that 495-degree angle the same thing as a 135-degree angle? And the answer is pretty much yes, and we'll talk about that in a second. There's a word for that. But before we get to that, just know you can have angles that go around more than 360 degrees. There's no limit to how big an angle can get. You can talk about a 7 million degree angle. It has just gone around and around and around many times, and then it's just going to be pointing somewhere when it's done all that spinning. Worth pointing out that even though in these drawings you can see these little red arcs here, that's just showing the rotation that happened. The angle itself has nothing to do with, or is not that arc. The angle itself is really that, the terminal side and where it's pointing. One last thing we can do that you possibly have not thought of before, if you can go more than 180 degrees and you can go more than 360 degrees, it makes a little bit of sense that you can also just go the other direction and have negative angles. So something that would have never come up in a geometry class is a negative angle. All that means is you have rotated clockwise from the initial side instead of counterclockwise. You've gone in that direction. So negative 210 degrees is, instead of a little bit more than 180 degrees into the third quadrant, it's a little bit more than 180 degrees backwards into the second quadrant. And so that's why negative 210 degrees lands in the second quadrant. One last little thing to add here, I mentioned it earlier, that there is a word for two angles that point to the same place. The word for that are coterminal angles. Angles that point in the same direction. It's really, really easy to find angles that point in the same direction. If you have, I'll get back to that in a second. If you have an angle, let's keep it simple, a 30-degree angle, and you want to find another angle that is coterminal to it, all you have to do is go all the way around the circle one more time. Let's add 360 degrees to it, and you'll find another angle that is coterminal. So all you have to do is add 360 degrees, and you will find an angle that is coterminal to a 30-degree angle. The example that you have on the bottom there is another pair of coterminal angles, 135-degree angle and a 495-degree angle, which is just 360 plus 135. Now, if you can do it once, you can do it more times too. So sometimes you're asked to find more than one angle that is coterminal with a given angle. And to do that, you can either just add 360 degrees twice. So the first one would be a 460-degree angle. And then if you do it again, you would get to another one that is 820 degrees. So 460 degrees and 820 degrees are both coterminal with a 100-degree angle. Notice how when we say that, you always have to say what it is coterminal with. There's no such thing as a coterminal angle by itself. It's not a type of angle, like acute or obtuse. Angles are coterminal with each other, similar to complementary angles or supplementary angles that come in pairs. One last quick point is that the other thing you could have done to find coterminal angles is gone in the other direction. You can always subtract 360 degrees also. And in this case, that would have given us negative 260 degrees. So I'll quickly draw this here. What we're saying is that a 100-degree angle, which is a little bit past 90 degrees into the second quadrant, is the same thing as a negative 260-degree angle. They land in the same place.